So, hello everyone. Good afternoon. Welcome to the knowledge session that is on exploring with Scala Cats. My name is Jitendra Kumar, and I'm a software consultant at Nasdaq. So, before going further into the knowledge, let's quickly have a look on knowledge etiquettes. The first one is punctuality. Please try to join all the knowledge session before 5 minutes prior to the session start time, so that we can start on time and we can conclude on time. Feedback, make sure to submit a constructive feedbacks of your all the sessions that you attend, as it will be very helpful for the presenter to improve their content into in the future for the knowledge. And silent mode, keep your mobile devices in silent mode. Feel free to move out of the session in case you have to attend any urgent call. Avoid disturbances. Please avoid unwanted chit chat during the session. Yep. So this is going to be the agenda that we will be discussing in today's knowledge session. The introduction of Scala, and then introduction to the Scala Cats, then modular structure of Scala Cats, in which we will be looking into the typed classes, then type instance, then type interface, then implicit class. And also we will be looking into the error handling that we do in Scala, in simple Scala, and how we can do the same in Cats also. And then we'll have a quick Q&A. Yeah. So a brief introduction to the Scala for those attendees who are not aware of the Scala, who don't know about Scala, what Scala is. So Scala is basically a programming language that supports both of the paradigms, object-oriented and the functional programming paradigm. Though it supports both of the programming paradigms, the object-oriented and the functional programming, but widely it is used for functional programming only, and it gives us the feature of combining the Java and the functional programming as well. Now, introduction to the functional programming. What functional programming is actually? So in functional programming, we basically focus on maintaining the immutability, and where functions are treated as the first class citizen, and the higher order functions are widely used in the functional programming. So here I have a question for you guys. If you are aware of Scala, if you do programming in Scala, uh, when you hear the statement like the functions are treated as the first class citizen in Scala or in any programming language that supports functional programming, what comes in your mind? What do you think that when anybody says that functions are treated as first class citizen, what do you think? Anyone? Am I audible?
Yes, Jitendra.
Yep. So I asked if anyone have any idea about the statement that I have used here. The functions that are treated as first class citizen in Scala. What do you think about this, Manish? Am I audible?
Yeah, basically in this we are going to code in function in which we are having the return type as a higher order function like that.
Yeah, partially correct. Actually, basically it means the functions can be treated as the values that as the normal value that we can use in Scala, a value that we can assign to a variable, yeah, right? A value that we can pass as an argument to any method, and it can be also returned from any method, right? So it is basically treated as the value. That's why it is called the first class citizen in Scala, right? Okay, so it promotes writing clean codes, maintainable code, and modular code, and bug-free codes. So from here, we'll start the introduction to Scala Cats. Yeah. So do anybody have any idea what Scala Cats actually is? if you a bit aware of the cats. Anyone?
No.
All right. So it is nothing but a library that provides abstraction for the functional programming in Scala, right? And it contains variety of functional programming tools uh, that allows us to choose and pick and use that we want to use. And majority of these tools are in the form of type classes. You're right. If you must be aware of type classes, the guy who are from Scala, right? So the cats is basically written in using modular structure, and the modular structure is based upon these two things: the type class and the implicits, right? And what are the type class, and what are the type instances, what is type inference? We will be looking into the deep into the session, right? So what are those? Uh, a type class is basically a trait in Scala, and a type instance is an object. Type interface is also in a object. An implicit class is basically used for getting better syntax. We'll have a look into the code, how we use these things into the code. Okay. And these are the key features of Scala Cats that Scala Cats provides. The type classes that we can use, reusable abstraction for generic programming, and data types. Data types means it gives the options either validated, and there are many more, like either T, option T for error handling and computations. And functional patterns like functor, monads, applicatives. There are many more, like semi groups, monads. So all those things, they will not be covered in this today's session, but I'll try to cover these things in my upcoming knowledge lectures, right? So basically it is an introductory session for the Scala Cats, so that we can start, sorry, so that we can at least start learning Scala Cats. Okay. And this is why we can use Scala Cats. It is simple to use in functional programming in Scala, and it supports, it promotes code reusability and composability, and it reduces the boilerplate code. So till here, if anybody have any question, they can ask. I guess no. So modular structure of Scala Cats. As we have seen in the previous slide, this is the modular structure of Scala Cats based on the type classes and implicits, right? So let's start from type classes. So type classes, basically a type class is an interface or API, we can say, right? That represents some functionality that we want to implement by extending or by implementing that interface or API. In Scala, it is represented by a trait, as I have already mentioned, and it basically takes at least one type parameter. We'll have a look into the code. Let me take you to the code, so that you will be better aware. You will get better awareness of how we can define a type class. Yeah. So I already have written down the code because of the time management. So yeah, this is how we can define. This is how we can define a trait or type class in Scala. As already I have already mentioned that a type class is nothing but a trait in Scala. So this is how we can define a type class. It is taking it is taking a type parameter of type T, and it is basically, for now, it has just one method, that is returning string, right? So this is how we can define a type class in Scala. Yeah. Next, the type instances. So type instances are basically they are for implementing the type of a class for a specific type, that whatever we are defining into the type class, we in the type instance we will be giving the implementation of those definitions here into the type instances, right? It provides concrete behavior for the type class methods for that particular type. Whatever type we want to implement for instance, if we want to implement for int, if we want to implement for a string type, or any other type we want to implement, we will do in the type instances. Let's see into the code how we can implement the same. Yeah, so this was the type class that we have defined here with the method. Now this is the these two things are the type instances, right? I'm wrapping these type instances into the show instances object, and this is how I am, instantiating or basically creating a new object, creating an object of this type class, or basically instance of this type class. And this is what we want to implement of the type. If you want to implement for the int type, if you want to implement for the string type, if we want to implement for the any other type, we will give here the type of the instance. And this is how I am overriding the show method. Basically I'm doing nothing into the implementation for now. I have kept the implementation for very simple for making you understand. The show method was returning in string here, and I am returning into the implementation. I am returning with some formatting. Just I'm doing nothing here. I am returning with some formatting here, right? So this is how I have created for int type, and this is how I have created for the string type. Are you getting my points, guys? Am I clear?
Yeah,
Hello, hello.
yes, you're clear.
Yeah, okay. So did you get the things that I have explained right now? The type class and the how we will be creating the instances of the type that we want to implement for the string, for the int, or for any other type, right? So let's move on to the slide. The next one is type interface. Once a type instance is defined, you can use the type classes method on that type, often in a generic context. Basically, it is nothing but a generic method that would take the a type implicit parameter of type class, and it could also take some other parameters that you want to pass from user side, right? So basically it expose the functionality of uh, that instance to the user. Let me show into the code. Yeah, yep, this is what I have I'm talking this is what I'm talking about. This is how you can create the interface. Basically the type interface, it is taking a implicit variable of type so, and it is also taking a value, a parameter, and of type t, and it is doing nothing but I'm just printing the values from where I have implemented it. I have implemented the type instances here. For instance, if you want to call this type interface for int type, it will call the int instance from here. And if you want to implement this interface for the string type, it will call the instance instance from here. And basically if you want to if you want to get access this interface, you have to do like this. This is the object that I have defined here, and within this object I have defined this interface. So you just have to access this method, and you just pass some value to this. For instance, I am just passing for now, I'm passing string value here, so it will call the string instance from here. and it will uh, format like this according to the implementation. And if I want to call the same for the int type, suppose 12, I'm giving 12. Now it will call the int instance from the type instances. Okay, so this is how, this is what the type interface is. Sorry, this one. This is also a way to create a type instance with the help of type classes basically. uh, Sorry, this is called a type class. With the help of implicit class you can create a type class. It is taking a value of type t, and whenever you want to access this interface, instead of this interface you just have to write the value and apply dot, and you will get the appropriate method to whatever method you want to implement, call here. You just to, if you want to call this interface, we just need to write the interface name, and this is done. So this is the another one way of creating the interface, and this is the another way of creating the interface. Basically the implicit classes are used to get the beautiful syntax support, as I have written here. So hope I'm clear till here. Sorry, hope I'm clear. Hello. So moving forward, type classes with cats. So as of now, we have seen that how we can create the type classes or type instances or type interfaces in simple Scala, right? We have to define, type classes. We have to implement the type instances, and we have to create the type interface as well. But how we can do the same in cats, using cats, right? So let's quickly have a look on the same. Yeah. So what you need to do is, here the cats provides predefined type classes and instances, right? We just have to import those type classes and instances, and there is a way to use them. Let me take you to the code how and see show you how we can use the same. Yeah, so we have to import the so interface, and also we have to we'll have to import the type that we want to use, right? For instance, I am creating a type interface of type int, so we'll have to import the int type. And if you want to create the type interface of type string, that you will have to import this string type as well. So this is how you can create the type instances. The uh, type classes are already created within the so interface. You just have to import them, and you can create the type instances, and you can use the and you can use them according to your need, right? So this is a very basic example that how you can use them. uh, Basically, let me show you one more example of type eq, that is basically used for comparing the instance types. And for instance, I'm creating the int instance for comparing the int values, right? Yeah, so we have created the type instance of type class eq. This was the type instance for type class so, and this is the type instance for type class eq that will be used for comparing two integer values, right? So let me show you how we can do this. It provides basically a method called eq that you can use for comparing the int values. This is the method that I'm talking about. Yeah. So what will it do? It will just compare these two values if they are equal or not. It uses basically three equal sign for comparing the instances of the type that you have created here. For instance, I'm creating the int instance, then it will compare these two values, two instances, right? And this is what I was talking about, that we have created using implicit classes for the better syntax that we can use. So you just have to import this API syntax.so, and you will be able to you know you just have to you explicitly no need to create any instances or instance or string instance or anything. You just have to write the value, and you just need to call that method, that so method, and it will done all the things automatically, right? So let me run this code and see what we get. Yeah. So this is the output. The first one output is because of this, that instance that we have created for now, and this one is because of this. And here we have compared two int values with the help of EQ type class, and with the help of creating EQ uh, int instance, right? So it is basically giving the true, because the 113 and 113 is equal, right? So this is how we can use the type classes in cats. There are a lot of type classes. I think I mean everything is most of the things are in the form of type classes that I have already mentioned in my slides. I hope I'm clear. Till here, if you have any question, guys, you can ask, please. Hello, am I audible?
Yeah, no questions.
Okay, all right. So let's see how we can do error handling in simple Scala, and then we will be looking at the how we can do the error handling in cats. So basically, in Scala, in simple Scala, the common approaches are to use try options or either, right? That is what we use actually in simple Scala for error handling, right? So there are limitations of that, like the verbose and less expressive. Expressive means the when we use options, some in some scenarios there we are not able to give the uh, more detail to the errors. What error occurred, we don't get the error details over there. So, and the one more I would say critical thing that we can't that is not very easy to do in simple Scala, that is error accumulation. If we have multiple errors, and if we want to populate those errors by accumulating them, then it is very hard to do in simple Scala. So that is what I'm going to do today. Let me show you into the code. Yeah. So here I have created a ADT, algebraic data type. Basically, I have created a data type basically for error handling. The scenario is we have to validate a bank detail. If we want to send some money to from one bank to another bank, then we need what we need, the the most necessary things are the bank account that where we want to send the money, right? And the amount, how many amount we want to send. So basically these are the error messages that we want to populate to the user. And this is the model that I have created here in the form of case class, that is that have a from account or to account, and the third one long amount. From account means where, from which account you want to send the money. To account means where to which account you want to send the money, and the amount. right? This is a very simple example. So this is here I am validating the account. So you know, no need to be worried about the things that is happening in this. The here I have just applied a very basic validation here, that the account number, the count of account number should not be less than 10. That is what I have done here, and the amount should not be in negative, right? It should be greater than 0. That is a very simple validation that I have applied here. Here the main things come here. When you want to, you know, we have two validations checks here. The first one is we have to validate the account, and the second one is to validate the amount, right? So if we want to populate both of the errors, like suppose the account number is not valid or amount also is not valid, so both of the errors we have to send together or in a list or something by accumulating them, right? So this is what I have done here, but as you can see the code, this is very complex. It seems very complex, right? So this is how this is the returned value from the account validation. This is the returned value from the uh, sorry account amount validation, sorry amount validation यहाँ से. And for the return types, for the error handling, that I have already shown you into the slides, that in Scala generally we use either or options for error handling. So basically here I am using either as return type of the these methods. So here suppose we get some values in these variables. In some variable we get, means we the validation is verified. In some checks the validation is not verified, right? So what will happen? I have used match here. So if all the values are giving right values, right, as we know the either returns two values, the left and right. Here you can see one is left and one is right. So in left generally what we do, in in left generally we send the errors, and in right we send the right values. So if the validations are verified, then it will return right of something, and if the validations are not verified, if the validation is invalid, then it will return left of something, right? So in our condition we have applied a match here. So if all the validations are fine, means all the values are valid. So if means if the from account is also right, and the to account is also valid, and the if amount is also valid, then in that condition the it will create a case class. It will create a model and send to the user where we have called this method, right? And in case of errors, suppose in case of errors, so one error will come in this, and one error will come in this to account validation, and one error could come in this. So all these things could have some errors, right? So here we are collecting those errors and we are accumulating like this, right? We are accumulating this error and in a list like this, and we are sending that those errors in left of something, because here also we have applied either of list of bank validation and transaction. If the validations are fine, then it will return the right of transactions, and if the validations are not verified, if any of the value is invalid, then it will return list of bank validations, means it will return with some error message. So this is, as you can see, this is a very complex code, right? For this was a very simple validations, though we have just two validations here. We could have many more validations. In that case, in those case, these accumulation could have a very hectic. So this is this the error accumulation is very tough in simple Scala. So that what we can do for doing so in cats, Scala cats, let me show you the same as well. Now error handling with Scala cats. Okay, let me show you the code by running it as well. So first argument was the to account. Mm, I'm taking some of the cases. So in first case, all the I have counted, like all the values are valid. In the second case, the account to account number is also a digit of 9, and the uh, from account is also a digit of 9, and the as you can see the amount is also negative. So let's see what we get in the console. As so you can see in the first case, right of transaction means the all of the values that we have provided here for the validation are valid, means the uh, from account is also of 10 digit, and the to account is also of 10 digit, and the amount is in non-negative. And in this way, in this case, the to account is from account is invalid, right? Invalid account number, and the two also invalid account number, and the amount was also invalid, like it is negative, right? You can't say you can't send a negative value to negative value, negative money. And in here, in this case, we have just invalid account number. Any of these account number is invalid, right? So we are getting the desired output as with the error accumulation, like we are getting all of the errors together. But the thing is that the doing so, the error accumulation was too hectic for us. So, for instance, we just have two validations here. We could have many more. We can have dozens of validations, and we could have more number of validations. So it will be very hectic to accumulate them all together. So let's go on to the slides. Yeah. So how we can do error handling in Scala cats? So we have validated, we have either T, we have option T, and with combinators, we have some other things as well. But in our case, I have just taken validated for, let me take this down, for this scenario only. Yeah. So these things are same, the error messages, and this is also the okay. The uh, validation for account is same. Validation for account is also same. Like it should be the account number should be the digits of account number should be greater than greater than 9 and 10. It should be 10 actually, and the amount should be greater than 0, right? So notice what I have done here. I have written the validation null as return type of this method, right? So in validation, validated null is basically returns a non-empty list. As you can see here, it returns a non-empty list of something, right? And if in write, it in write basically it will return the string. And in validated here, it has a method that called condition. Here you can give the condition, whatever the predicate you want to apply. your account number should be, should not be less than 10. And if 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 that happens, it will return the account number is invalid, right? So basically, instead of writing this, you can write one more thing. We can write here, we can write validated and a non-empty list, right? So both of these things are same. Both of these things will work in the same way, but the validation nil returns non-empty list automatically. So that's why we don't need to write these things explicitly. The NEL means it stands for null empty list, right? So what we have done here, we have just applied the basic validation check, nothing else. And in here we are just calling those validations, right? We are calling those validations here. We are calling the account validation. We are I'm calling the amount validation, and I'm mapping those things with the transaction, right? So what map n does, it basically, if the it runs in two way. If the validations are fine, right? If all the validations are verified, if all the values are valid, then it will create a transaction case class. It will create a model, right? It will create a transaction class from here, and it will send to the user where whenever we have called this one, right? And in case of any failure in the transaction, like if the amount is in negative, if the account number is not valid, then it will accumulate those things in non-empty list. The map n will accumulate those errors in the non-empty list, right? So let me run this code as well, and let's see what happens. Yeah. So in the first case, here in the first case, all the values are valid. The account number is valid, the from account is valid, and to account is also valid, and the amount is also valid. But in the non in the second condition here, it is returning invalid, right? Why it is returning invalid? Because the validated returns have two things basically. One is valid and one is invalid. If the validation fine, validation gets fine, then it will return something of valid. And it, if the validation are not fine, if the validation is not verified, then it will return invalid of something, like here. Here, so this is how we can leverage the Scala Cats of doing so, like uh, the error validation and other things. So in today's knowledge, I have just started the Scala Cats, introduction of the Scala Cats, how the Scala Cats is basically more powerful than simple Scala, how we can leverage, how we can get more benefit of using Scala Cats. So in this today's knowledge session, that was the only thing that I had to discuss. I hope I will get more chance to give more knowledge. So I will try to explain more things, like monads and semi groups and other things. So I'm done with my from my side. If you have any question, you guys can ask. And these are the references that I have taken from the content that I have taken from. Himanshu, I'm done from my side.
Thank you, Jitendra. Guys, if you're having any queries, can we come up with it quickly? If not, I suggest you guys to kindly get in touch with Jitendra later on Teams if you are having
Yep.
any queries. Queries. Fine. I guess we are going to wrap up from here. Thank you, Jitendra. Thank you everyone for joining. Hope to have a great weekend ahead.
Thank you everyone for the joining. Thank you.